Hi, welcome. Let's just wait a couple of minutes so that we can wait for people that are still entering the live stream, and then we'll start the presentation. Thank you. So, thank you for waiting, and we'll just then start the presentation with the people that we have, and if people join down the line, they can then catch up after. Welcome once again to our presentation. We hope you enjoy your stay and that you learn with us, even if it's just a little bit. I'm Alexander. I'm part of the export sales team of barpa, and anything you need, you can contact me. This presentation will be about the newest barpa GPON solution, which we have been developing for a while now. And we wanted to guarantee that we would have a solution that would stand out from others and that was easy to understand. We developed as well so that we could produce most of our products in Europe. This presentation will not have any answered questions live that are made by anyone, but if you ask them on the live chat on this live stream, we will have people to answer you by text on the chat. So if you feel the need to, please go ahead and ask them. So let's start with the presentation. The objective of this presentation is understand the PON and GPON networks, the difference between the traditional LAN and the PON network, the key advantages of this solution. We will also explain how barpa's GPON solution works and their respective products, and we also talk about some future technologies. To have a base to go on, in the 80s in the 80s and the 90s, the optical communications revolutionized the long-distance broadcasts. Today, the fiber optics are the backbone of most providers of telecommunications. This technology has shown to be far superior comparing with copper in terms of bandwidth, energy consumption, security, and even the trust that it provides you. So, before we talk about GPON, it's important to understand what PON, and FTTH, for example, is. Keep in mind this FTTH is an example, it could be any other FTT related. So PON networks is the mother term of all network architectures that comes out of fiber optics, which in this case are pole on the left side, which is mainly used for commercial buildings, enterprises, hospitals, education, etc. And the FTTH or FTT your preference, which is made for houses, apartments, and small businesses. With this image, you can see clearly how the GPON and PON are related. In this case, and as you can see on this image, the PON is the road and the GPON is the car, which means that for the GPON, which is the network to go at its maximum speed and run smoothly, it has to have a decent smooth road, which is the pole. So if you have a good pole and you have a good car, both work together, both will have better results. In a pole network, you can use normal Ethernet, GPON, XGS-PON, or NG-PON2, etc. And for a better understanding, there are always two types of network architecture. Point-to-point network, P2P, or point-to-multipoint network, P2MP. On the point-to-point network, this architecture will always have a fiber installed directly between the client and the central office. The central office being the one that provides you the downstream and upstream. And the advantages of these point-to-point network are they allow you for a high transfer upload speed and a better service, more flexibility and more security. But the disadvantages are a bigger initial investment on the setup of the additional fiber that you're going to use on this network, a bigger occupation of a physical space and bigger power consumption on the central, because it implies an optical terminal laser through a client which normally is the OLT. As you can see on this graph, there's OLT, which will then have a fiber directly connected to each point that provides the downstream and upstream. And the OLT, if you want to know, ONT is the optical network terminal, and the OLT is the optical line terminal. Then you have the point-to-multipoint network. This architecture always provides you with a harbor in the OLT per X clients, per a number of clients. As you can see in this image, the OLT is the central, and then has a kind of switch that provides for each point, multi-point. Each switch is able to provide to multiple clients. So also keep in mind that this architecture, the point-to-multipoint architecture, will be our main focus as our solution, because we are more directed to enterprises, and this is the one that's used mostly on enterprises. And before going forward, I think it's important to know the main differences between a traditional LAN network and a PON network. And as you can easily see, the left side is the traditional LAN network, and the right side is the PON, the passive optical LAN. And as you can easily see, there's a distribution layer, and on the distribution layer, which is the significant change, there's just one device, the OLT on the pole, which will provide the service to multiple ways that you prefer. And on the traditional line, as we already know, there's multiple switches that then separate into a lot of things, active devices. Some advantages comparing with a traditional LAN network. As you can see here on the sides, there's limited distances on the LAN compared with a pole network. The pole network, you can even go to 20 kilometers with no problem. And in the end, with a simple structure as this, you can provide the client with automation, voice, data, video, CCTV, or wireless. On the pole going deeper into the GPON technology, as you can see on this image, as I talked before, there's an OLT with splitters that splits into houses, and then the houses, there's another splitter that then you can even separate between floors if you want to, so that you have a better connection in all the building itself. So the GPON solution always follows a certain standard, which is the general standard, that is because it must be distributed through monomode cable, simplex connectors, passive optical splitters, or PLC splitters as you prefer. The connectors of the fiber should be APC connectors to supply terminations that minimize the impact of attenuations or return losses. And there are four components of a bigger importance: the OLT, the active device, the cabling and its components, the optical splitters, and the ONT. We will talk about each of them further. So the key advantages of this solution are a fully plug-and-play system which provides you an easy installation, an easy planning, easy and fast planning, a fully flexible system, and no fusion splices at all. And you'll also have cost reduction and less space needed with a simplified maintenance. This will provide you with a simplified maintenance, less cables, less cabinets, centralized management, no secondary cabinets. It will also have a highly secure and reliable system, no crosstalk between cables, no electromagnetic interference, which are very experienced in copper cabling. The downstream encryption is AES-128 as well. As an energy consumption reduced, which gives you a green architecture with less switches, UPSs, air conditioners, uses less space because of the decrease of the active devices, less cables, and it's easier if there's, imagine a fire, less cables, it's easier to put it out. It also offers voice, video, and data and other IP services, a scalable infrastructure designed for the future, as you can see here below my camera, 10G, 40G, and 100G. Longer distances, broadcast in various locations worldwide, less quantity and dimension of cable trays, and a high bandwidth. With this solution, keep in mind that in the high bandwidth on the GPON right now, on the traditional GPON, the downstream is 2.5 gigabytes per second, and the upstream is usually 1.25 gigabytes per second. Some pole applications are offices, universities, hotels, casinos, museums, airports, factories, hospitals, and clinics. And then this is, in a simplified way and with labels, our solution at the moment. You can see here that these numbers are related with the labels on this graph, and our solution consists of a patch cord SC to SC APC, a splitter patch panel which is the first level, a fiber patch panel which is optional. It's not if you don't want to use it, you don't need to use it. A backbone between the main cabinet and the distribution box, a cable, a backbone, a distribution box which is on the second level, as you can see here, a cable between the distribution box and the ONT, which is also here, which is called normally a horizontal cable, a single fiber, and then a ONT, which is a device that will provide you with Wi-Fi if it has a Wi-Fi, and the user socket if it's meant to go to the user socket. With this, I'm gonna show you our example, because we did an example right here on our showroom, so that you could see with your own eyes and have a visualized idea of what could be a GPON solution. Please keep in mind that this is not the thing to follow always. It can be different than this. So, as we talked, there's a patch cord SC right here, and then there's a patch panel splitter right here as well, an OLT, which in this case we chose Ubiquiti, the U-Fiber models of them that are very good, but if you want to use a different device, you can, it's the same. Then you have a cable going through the back, which is the backbone that connects the splitter to the distribution box, which this distribution box and the patch panel splitter was both developed specifically by us, so that you could have a better experience. And with this distribution box, you have the option of either installing it vertically or horizontally, which means that we had to put an entrance either on the side or on the bottom, and so that when you install it horizontally, you can put an entrance from below as well. Inside there's a mini type PLC splitter that connects to a double layer front, so that you can with a better security place your connectors and adapters. Then there's as I said, the horizontal cable that connects from the distribution box to the ONT, which then will provide, if it has, which in this case it has from the Ubiquiti, which in this case has wireless, or from below there's also connections to if you want to connect to the socket. So now that you have a visualized idea of what could be a GPON solution, we also developed this image, which will also, by the way, I will take this chance to tell you that we are also soon releasing a ebook about GPON, so that you, when it's released, you can go deeper into detail about everything we are talking about today, so that you can have more info, more detail of everything we're talking about, and then you'll learn even more. And this image will be present on the ebook, so if you don't catch it now, you can catch it on the ebook, so don't worry. But on this image, you can see an example of, in this case, a building of offices, of an installation of the GPON solution. In the one, if you can see that there's a label for everything. On the one, you have a splitter patch panel on the server room, or however you want to call it, a splitter as well, and then which splits to a distribution box. This distribution box will then split into various fibers that then you can connect to each ONT or box to then connect to the ONT which is located either in the desk, either in the wall, however you prefer. In this case you have it in the wall, but it can be in the desk. You can also connect directly from the distribution box, as you can see here on the 5 label. You connect directly to a access point. And of course there's the OLT, which is the label 8. There's OLT, which is the one that manages the service of this building. Keep in mind that this is an office, building of offices, but it could be an hotel, distributed the same way for each floor, and then separated to each room, and then have fiber to the room as you may prefer. So now I'm gonna show you our solution more closely. Our splitter patch panel, which is the first product that I'm gonna show you, which is here. This is an example. Please keep in mind that we have various configurations. Even that configuration is different from this one. For example, this one has an I and O, I for in, O for out. In this case, 1 goes in, 8 then goes out, O1, O2, etc. And the same for 3 times. In this case, on this solution, it's 1 in, 2 out. Then we have the fiber patch panel, the usual fiber patch panel, which you can find on our product line since before this even started. And the wall-mounted distribution box, which is that one that's right there, but I'm going to show you anyway, which is this one. And as I told you, there's an entrance from the side and an entrance from below, so that you can install it right like this, horizontally, or you can install it vertically like that one. This opens for an easy management, and inside you can see that there's the mount for the entrance of the fiber, and then there's the double layer right here. There's the double layer so that you can securely fit in the adapters and the fibers. And the whole layout for the splitter is inside here, as you can see on that box. Then the mini type PLC splitter, which is this one. barpa also can provide to you easily with various configurations. We have different configurations, more fibers, less fibers, whichever you prefer. A wall termination box, which is this one, a simple tiny wall termination box with a even as a protection. An adapter, which is the usual adapter that we already have from barpa. And then, what makes our GPON solution stand out from the others normally? We started this whole process with our pre-assembled fiber cables. We developed our own project, which is called Higgs, as you can see here, to provide you with tailor-made pre-assembled fiber cables. This makes our solution fully and truly plug and play, because Higgs has pre-assembled high-quality cables and has a wide range of configurations possible. The advantages of going through these tailor-made pre-assembled fiber cables are, of course, the main ones, the installation, which it's easier and the cost is very reduced. These cables are always fully 100% tested and with total traceability. And of course, you have the guarantee of quality of the production in a laboratory. It also eliminates, of course, the need of doing fusion splices in the field. We also have the cabinets, the usual cabinets that barpa already had, the server cabinet, if you prefer a rough cabinet, the server cabinet, network cabinet, open cabinets, wall-mounted cabinets, and the rest. Then you have the copper solution, which we already had and we have been developing through the years, with the cable, with the field plug RJ45, patch cords, keystones, patch panels, etc. So after talking about this, it's important for us to talk about the downstream and upstream. Please keep in mind that this is illustrative, and I just want you to explain which are which, so that after you understand the attenuation and the losses. The downstream is always what goes from the OLT to the rest, to the clients, which surpasses all of these devices to then reach the end user. And then you have the upstream, which goes from the client, from the other side, to the OLT. That, of course, as you may understand, always makes some kind of losses between each other. That's why there's standards for these kind of things. Always. PON networks are tested the same way that traditional fiber optic networks are tested. Every bit of cabling should be tested according with the standards IEC, the normal ones, IEC, AN/SI, and EN. The calculation of attenuation of the channel includes all passive components, cable, connectors, patch cords, fusions if used, adapters and splitters. And as you can see on this little graph, you can see that this is the usual standard, and you can see here which standard it is as well. This is the standard for each class, in this case B plus and C plus, for the maximum supported distance, the loss that's allowed, and etc. The calculation of the attenuation of the pole channel depends of several factors. The length of the connection, how many kilometers there is in the connection, specifications of the used devices, OLT, ONT, brand to brand it will differ in various ways. The used topology, the splitters plus the connectors, and the safety margin, which is made usually there's always left on safety margin for future expense and maintenance. Here you can see an example of a calculation of attenuation. There's the connection length, number of connectors, number of fusions, number of mechanic fusions, number of PLC splitters, and which are of them and which were used, and then there's the calculation and which safety margin should be used for that project. And if you need help with that, we also are available, of course. Some future technologies. Please keep in mind that when the direction of the evolution of the pole solution is a high interest for the whole community. A positive aspect of the GPON network is that it is possible to evolve to other networks, such as you can see here in this table. You can see that you can evolve. If you install GPON, in this case, you can then evolve in the future, if you want to the XGPON, for example, which will give you a faster downstream and upstream, bigger distances, and more users if you want to. And because this happens because the physical structure is the same, always the same, and you can use this graph to see the main differences between each other, which you just by looking at it, you can see there's a big difference between each other. So PON and GPON networks are gaining importance in the market day by day because of all its advantages: flexibility, cost reduction, etc. At barpa, we present a solution fully plug and play to bring more value to the installer and user. This is possible because of because of Higgs, because we developed also this big project Higgs that provides you with pre-assembled cable patch cords, zip cords, whichever you would like to use. Even though it's not always applicable in every scenario, this architecture has come to stay, and it offers very interesting solutions of a better bandwidth and security, as we told you before. So thank you a lot for being with us here today. It was a pleasure for me to do this presentation for you, and we do hope that you learn a lot about the things that we talked about today. And please do not forget that soon we will release an ebook of GPON, so that you can then take these information that you learned today and then go in even deeper into the GPON solution of barpa and the whole infrastructure of what GPON is. So thank you and goodbye. Hi, welcome. Let's just wait a couple of minutes so that we can wait for people that are still entering the live stream, and then we'll start the presentation. Thank you.